Welcome to this MVA course on Azure Mobile Services and API Management. We're here recording in Redmond on a very chilly morning, hence I'm wearing my generically branded jacket. But we've got some great content in store for you on both Azure Mobile Services and Azure's new API Management platform. Let me introduce myself. So I am Josh Twist. I'm a program manager lead in the Azure API Management team. And I was a founding member of the Azure Mobile Services team as well. I'm also here with my esteemed colleague, who I'll let introduce himself, Vlad.
Hi, I'm Vlad Vinogradsky. I'm a program manager on the API Management team, and I've been working on API Management for a few years now. And before that, I worked in the industry in the various technology roles. So it's great to be here.
So let's take a look at the topics that we have in store for you today. So we're going to talk about 4 modules. The first one we're going to talk about briefly the API economy and API management. That'll be Vlad and I. And then we're going to bring Kirill in, who's going to talk about mobile services and working with data, corporate login and offline synchronization, and then finally push notification patterns. So some great subjects that we'll be covering in the modules. I want to make a call out here for the MVA community. This is an awesome community. The content that's produced by these guys is just incredible. And that testimony to that actually is the fact they've just crossed 2.5 million users. So take advantage of this awesome resource, get in there and use it. And obviously you already are because you're using it now, but use it for everything else as well. So I think we should probably get started with the first module, which is all about API management. And to set us up, let's take a quick look at what we're going to talk about in this module. I'm going to talk briefly about the API economy. And that'll guide us into talking about why we created this service, and specifically then, what is API management? What is this notion? We'll take a look at the logical architecture of the solution that Azure offers in this space, and then we'll get into some fun and meaty demonstrations. So let's spend a little bit of time on the API economy. This notion of an API economy means many things to many people. At the heart of it lies this unprecedented growth in the number of APIs, and that's triggering an enormous increase in the connections that are being made between businesses, governments, and their citizens. Partnerships are now happening at an incredibly fast speed, and that's where we think we can help. So we have a solution that can help you industrialize partnerships. It used to be that to make a partnership happen, say between 2 businesses, for example, that we'd have 2 boards come together from 2 different businesses, contracts would be exchanged, and then eventually there'd be some partnership perhaps using an API. This has been happening for years, for the last 10 or 15 years. But just recently we've seen a real change in this internet era where partnerships happen in the click of an instant, just in a real flash, where even individuals, not even businesses, can go to a business now, sign up on their website, get an API key, and become a partner with that business. We just see this happening all the time. So if we look at the growth of APIs recently, you'll see that there's been this huge exponential growth curve in the number of publicly registered APIs. Underlying that are even more private and internal APIs. A lot of people talk about it like an iceberg, where the public APIs are the tip, and underneath is this behemoth of private and internal APIs. And that's being fueled by mobile, social, cloud, open, big data, Internet of Things. All of these internet era technology motions are driving a huge growth in APIs because they're all dependent on it. APIs are increasingly becoming a core way that businesses actually do business. In some cases, APIs are like the retail storefront for a business. Take an example like Twilio, who have a public API. Their API is how they do business. It's the same as a store having a retail storefront. Also, what we're seeing is that APIs are triggering a huge growth in innovation in enterprises. People are looking to use APIs internally to allow their businesses to move faster and faster. And the minute you want to take advantage of this space in your business, in your enterprise, then there's a few things that are going to block you. There are a few things that are in your way. So let's talk about those. And in doing so, let's talk about more about what API management means. So hopefully you're convinced now by the small chat we had on the API economy that you need an API program. You need the idea of being able to fast-track people being partners of your business or internally sharing APIs in a very efficient way to drive innovation. But the minute you make that decision, you face a number of obstacles. How are you going to engage with developers? I suspect many people watching this MVA course are developers themselves, and you'll know that developers are a finicky bunch. We like our documentation to be really, really good, really strong, really consistent, easy to read and accurate and up to date. Also, as a developer, I want a way that I can communicate with the API publisher and let them know that I'm having a problem with the API, or I like the way this works, or I don't like the way this works, or I don't understand how this particular aspect works. You have to create a bi-directional channel for developers to communicate with you. Also, we need to reduce something called the time to first successful call. So this is a measure that API program and companies that have API programs use today to think about how long does it take for when a developer decides to try your API out to actually successfully get a transaction flying through the system. How long does it take them to do that? We call that the time to first successful call. How do you enforce business policies? So if you think about having an API that you're going to sell, that you're going to sell things through an API. Perhaps you sell bundles of APIs. You have a starter pack, just 100 API calls per day, or you can go up to a premium package where you get a million API calls per month. Then those quotas are your business policies, and the way you bundle those into products is yet another thing that you'd have to be concerned about. How are you going to solve that problem? How are you going to make an API modern? Many businesses today already have the right data and services to expose, but they're in some legacy format. They're a SOAP or an XML-based service. It's very hard for an iOS developer to call such a service. They're much easier if it's JSON or REST or using HTTP. How are you going to project a modern facade over your existing, perhaps dated APIs? And how are you going to understand the behavior of your API program? This is super critical. Imagine you were going to launch a marketing campaign. You were going to stand up a website that published your latest product and made it visible to humans. Then you would expect, it would be unthinkable that you wouldn't plug in an analytics solution so you could see how popular is the campaign being, how long are the web pages taking to load, where is the traffic coming from, what does that demographic look like. Your API is exactly the same. You need to understand which developers are using your API, where is the traffic coming from, is your caching policy actually working, what does the performance of the APIs look like, have you had a sudden spike in errors. All of these things apply to your API just as they would to your website, with your API effectively being your digital presence. And how are you going to protect your core business systems? I'll tell a very brief story about an experience I had back in industry before I worked at Microsoft. I used to work at a large travel consolidator in the UK, and we actually went through the process of one of those old-fashioned partnerships where the two board teams met from each business. They got together in a room, made some agreements, and we decided to do a revenue sharing model where they could resell our flights on their own website. Now, my job as a developer at the time was to go and build an API they could use. And within a week or so, we had an API. Everyone made a lot of money. Everyone was very happy. However, after a week or so, something bad happened where some code in the partner's solution actually flipped into a bug, ran into a for loop that ran infinitely and DOSed our service. It actually brought down not just the API we'd created for them, but our internal mission-critical systems, and worse still, it actually brought down our public-facing website as well. So you can guess what happened next. I went into work the next day and I had to build a custom rate-limiting solution. So how are you going to solve these problems? Rate limiting is a non-trivial problem. All of these problems, we think, fall under the banner of API management. And so we have an API management solution in market today that is a turnkey solution for these issues. So let's take a quick look at the logical architecture of the API management solution Azure offers. So Azure API Management, as you can see in the center on this slide here, is comprised of three things. There is a developer portal, a high-performance proxy, and the publisher portal. So the publisher of the API, let's imagine I'm about to take an API and make it into a business, let's say. Then I'm the publisher. So I go to the publisher portal in Azure API Management, and I use that portal to configure both the developer portal and the proxy. And what I do is I tell it about my existing API. So I'll create the API and host it somewhere. We'll talk more about that in a moment. So I've created a developer portal now that contains documentation that was generated based on the metadata that I entered into the publisher portal. And we'll take a look at this in just a few minutes. So developers or partners can now come to that website, sign in, and get access to our API by signing up and getting an API key. Those developers now create applications and services. And those apps are going to talk to our API proxy, which forwards the traffic to the original API. So we become the new front door for your API. And that API can be hosted anywhere. It can be hosted in Azure, which we love, but it doesn't have to be. It can be hosted on premises, can be hosted in a rival cloud provider. As long as we can talk to that via HTTPS, then we're good. The proxy is where the magic happens. So that proxy that you saw in the middle of that slide, we can do all kinds of things in there. We harvest the analytics about the solution, and we can even do transformation to change the way a response looks. So let's imagine that you have an XML API. We can use the proxy to dynamically turn that into a JSON API just using configuration. So that's API management and how it's laid out, and at a very high level, how it works. I think we should take a look at this in more detail now. And so what we have is a demonstration now, and Vlad is going to drive us. Vlad is our product expert here. Vlad's going to drive us through this and take us through an example of API management and just how easy it is to use, right, Vlad? So you're going to show us how quickly you can get started with this solution and what it looks like to give it a whirl.
Gladly, yes. So let's start with Microsoft Azure portal, management portal. This is where you can create new API management services alongside any other Microsoft Azure service. It's a really very simple process and familiar to everybody who used Azure before. And essentially, it's a quick two-step process. You just give sort of a prefix for the domain that you want to have for your APIs, and then choose where you want to locate your service. And we support most of the regions for Azure, and pretty much that takes care of it. So I already pre-created a couple of services, and we're going to look at one of them. So if you dig into a service, what you're going to see is very familiar sort of dashboard that all Azure services have. It has some basic information about the traffic, about the status of your service, and most importantly about your API that is IP address that is stable for the lifetime of the service that you can use to set your firewall rules, to lock your firewall down to just this particular IP address, so that we serve as a front door and the only front door to your API. There's also a scale tab which allows you to choose the tier or upgrade or downgrade the tier of your service, as well as pick the number of units, which are basically units of capacity to handle traffic. And then lastly, there is a configuration tab where you can set custom domain names for your developer portal and for your API, which you most likely would want to do, and then of course secure it with SSL certificate. So that's sort of the basics of the service, but the actual management of your API program is happening in the publisher portal that George just told you about. And to jump in it, you press this button, Manage. And essentially what happens is we get redirected into this publisher portal where you have full control of your API program. So you land on a dashboard view, which basically gives you sort of a 10,000 feet level view of your APIs, their basic metrics and the issues associated with them, if any. This Echo API comes pre-installed with the product when you create a service, just so you can get started and start playing with the system very quickly. We also, of course, provision immediately developer portal. Again, Josh showed you on the diagram, and that portal sort of is nicely styled, but obviously it can be restyled to reflect your brand really easily. So we're going to come back to this portal and explore it more, but we're going to kick off with just adding an API. That's probably what you want to do, right? API management starts with actually adding an API that reflects, or rather, represents your backend service you want to expose for outside consumption.
Awesome.
So there's a few ways you can add API in. One is to import it, and we support a couple of formats that are popular among developers these days. Alternatively, you can add it manually, and that's the route we're going to take for this demo. So to add an API, you have to name it. But before we go in and execute this step, let me show you the API we're actually going to be adding. So this API resides at this URL, and it's essentially a very simple API. Simple API, which essentially does have only one operation of adding two numbers that are supplied as query parameters A and B.
And that's just a plain web API hosted on Azure cloud.
Yes.
Cloud roles?
Exactly. So this API is just, I think, running on websites or as a cloud service. Can be anywhere as you described. Again, very simple, just to show the basics of the platform.
Cool.
And of course, I can call it, and the call is successful, and this is the response we're getting. Note that it's XML, and essentially it contains the sum of the two values, 99 and 1, that was supplied as query parameters.
Oh, cool. So this is a calculator API that adds numbers.
Exactly. That's exactly what it does. And note two things about it, which are sort of important, which we will change through API management. Mm-hmm. First, we're going to simplify the way this API is invoked. We will go from query parameters to path parameters, which is sort of more modern style. Cool. And also we'll enable JSON formats as well on this API. So we will make sure that it's sort of modernized a little bit. So with that, let's go back in. So what do you want to call this API, Josh?
Oh, adder.
Adder. Very good. So I need to plop down the URL for this API.
So that's the backend URL. That's the existing backend.
That's exactly right. So I'm taking this API right here. In fact, I should grab the last part of it as well.
Cool.
Now, all these APIs that you're going to be onboarding into this service will be hanging off of one URL, this domain URL for this service. And they will be distinguished by suffixes, URL suffixes. So we need to pick one, and I'm going to pick calc.
Makes sense.
Note that you can expose this API either through HTTP or HTTPS or both. Mm-hmm. We're going to just leave defaults, to go sort of the choose secure route, but you can obviously choose both. And at this point, this is essentially it, right, for this dialog box. So we are creating a new API. At that point, we basically registered an endpoint, right? So there is an endpoint that is pointing to this calc API, is registered with API management. Now we want to create operations. Operations essentially represent a whitelist of resources and verbs on those resources that are allowed and exposed for outside consumption. They can represent subset of the functionality available through the web service, which is basically creates sort of a facade over it. So let's add an operation, and that operation will use get verb, similarly to how the service works. And as you remember, the subpath for that was add, right? And then it takes two parameters, A, with the value of A, and then, of course, B, with the value of B. And that way, essentially, if we're registered that way, it's going to be straight path through. But do remember we discussed that we actually want to modernize this service and actually change the signature, if you will, of this operation to take path parameters versus query parameters. So what I'm going to do is I'm going to actually create what we call rewrite policy. And what I'm going to do here, I'm going to replace the facade URL with a simplified version, which looks like this. So we will be taking those parameters A and B as path parameters versus query parameters.
So effectively, the proxy is changing what the API looks like. On the front end, it's now the API that the apps will consume, that those developers build, will now use add/A/B.
That's correct. Awesome. So essentially, what we already changed facade URL, right, for this API, for this web service. We're also now changing the path for the resource to include path parameters and map it to query parameters that the backend service understands, so it, of course, doesn't have to change or be modified. So what would be the name of this operation?
Oh, number adder.
number.
Just to make it different.
Okay, and then of course you can add description and we're going to go with a sparse documentation for now, just to show you the basics of the platform. But obviously, more information you provide here for every operation, API, etc., every artifact in the system, better off your users are going to be, because all that information will be used to generate developer documentation automatically for the developer portal. So more effort you put here in documenting various aspects, better off your documentation is going to be, much simpler.
Oh, that's awesome. So you're entering metadata now that describes your API
Exactly.
that will be used to generate the developer portal that we talked about before.
Yes, absolutely. That's
Awesome.
exactly what we're doing. Cool. So with that, let's save this. Very cool. So we have number adder operation. So at this point, we have an API. We have an operation on it. There's one last step that we need to perform here. We have this concept of a product in API management, and product is actually an aggregation of APIs. Essentially, it can have one or more APIs associated with it, some terms of use, and some consumption limits. And that's a really nice way to to add a level in direction how you publish APIs to developers. Imagine that you can publish the same API using different terms of use and consumption limits for your premium customers versus your basic customers versus your free customers, and do all sorts of things. So it's a great concept for packaging your APIs and making them available to your developers. So here I have a couple of products that came with the service, by default. So I'm going to just reuse one of them, but of course you can create one.
And if I create an instance and I don't need these, I can just delete them, right?
Oh, yeah, of course. I mean, all of these artifacts that we create by default are just to get you started, but you can essentially go and delete and clean out the service and start fresh. But in the interest of time, I'm going to just use the one that we have here. So it already includes Echo API, and we're going to just add our Adder API to this product as well.
Cool.
Done, right? So now we have both. So at this point, we can actually go and test this API. So if we entered everything correctly and wired things up correctly, then it should work. So let's go and make sure.
So what this experience you're looking at here, this is the developer portal experience, right?
Exactly.
This is where your partners and developers come to learn about the API that you just entered effectively and published to the world. So now it's available. Cool.
That's correct. So we are now in developer portal experience. As you can see, as an administrator, I have the option to manage, and then of course I can jump right back into the developer portal experience.
Oh, I see it even has a sign up button down there. So that would be for a new developer coming to this portal.
Absolutely.
They click sign up and create an account.
Exactly. And we can demonstrate this a little bit later, how that works and what sign up options we have. But so just to quickly test this API, we can go into the API section, and we can see Adder API right here.
Wow.
It doesn't have a description since we didn't add one, so that's sort of the benefit. And as you can see, parameters essentially are very sparsely documented, but we could have added their descriptions and types and all the other things. So let's go into the console and add 49 to 51, which should, hopefully add to 100. As you can see, subscription key, which identifies me as a developer and also identifies the product, that includes this API, is selected for me, but, I can select a different one, and I'll show you where this key is coming from. As an administrator, I'm automatically subscribed to all the products, so for me, there was one less step, but if you are a developer coming to this portal first time, you sign up, and then you can go and pick a product you want to sign up for, and you click through terms of use, and you get subscribed, and at this point you get a key, which gets populated here, and you can call it. So let's go and invoke it, and let's hope that everything was wired correctly, and it was. And as you can see, we executed this service from the developer portal through the proxy, got the right answer. Also note, as an admin, I have this header set up here, which sort of preset for me automatically, which allows me to actually receive this tracing information that I can actually take a look at and see exactly how the request was processed and what operation was mapped and how each step of the proxy processing, how long it took, if there were any issues or some errors that I made during entry where I didn't map URLs correctly, or I entered made a spelling mistake in operation name or path name or whatever. This is a good way to debug it as you an administrator. That capability is available to you.
Fantastic. So just for a second to come back to what you just shown there, because I think it's huge. You just showed how you can go to the developer portal. There was a button that said Open Console.
Yep.
You click on that button, and that means this is an experience a developer, one of your partners, could have.
Yep.
He gets an automatically generated form that allows him to invoke the API in real time and try it out.
Exactly.
And so that comes back to that point we made in the chat about API economy,
Yes.
where we said time to first successful call. So imagine if you're a developer trying to learn an API, you can just go to the documentation, you get this beautifully presented documentation. Then you can go to a console where you can try that out in real time and actually invoke the API and see the results. There's no better way of learning an API, right?
Very true, very true. And as I'll show you developer sign-up experience a little later on, but any developer, not just managers, will have this profile menu item that they can go to, and they're going to see the profile page, which actually gives you information about yourself that you entered into the system, but also, most importantly, all your subscriptions and all the keys that are generated. We generate 2 keys for each subscription, so you can implement key rotation policy. So you can obviously regenerate keys at will. You can look at them. You can copy and paste them into your application. You can cancel your subscription from here. And most importantly, as a developer, you probably want to know, your patterns of use of the API, and if you build an application, how that application is using the API and how much of it, API sort of operations you consume, and et cetera. All the information that you might want to know is available to you as a developer. So essentially, you can go into this section, and we're going to look at analytics for the publishers as well. But basically, we give you a lot of information as a developer to understand exactly how you're using the APIs that you subscribe for.
Oh wow! So if I create an app, I'm the developer, I create an app, I can see this report that you just showed on screen there, showing the geographical location of API calls, etc., for my application.
Absolutely,
Right.
and you can also filter those statistics by the product, by the API that you're using, etc. And this is, statistics that are available just to you regarding your use of the API. Obviously, publishers in the publisher portal, and we're going to see it soon, maybe at the end of this session, you'll be able to see consumption across all developers, obviously, awesome. Right? But this is just for you. So let's jump back to the publisher portal. And at this point, you can see that I have this Azure API. Analytics is sort of a little bit of running on the background. So we will see data appearing pretty soon, I hope. Call data for this particular API. But what we're going to do now is we're going to look at the policies. And policies are essentially pieces of functionality that you can add to your API on the proxy, which change either the form of the API, like rewrite policy, or the behavior of API. And then examples of those would be content transformation or caching, without actually making any changes to your backend service. So these are kind of value-add things you can apply to your backend service to make it more optimal for the scenario you're trying to address by exposing the API. So let's go in the policies and do this other thing that we wanted to do is to enable JSON response type from this particular web service, which knows only XML. So let's modernize it that way. So as you can see, policies can be set at a range of scopes. Global scope, where they will apply to everything. They can apply to a specific product. They can apply to a specific API or operation. And so in this case, I'm going to actually set a policy on the API, on the Azure API, which will apply across all the resources if we were to add more resources to this API. So I'm going to click Add Policy. I get a little bit of XML here. And as you can see, we have ability to apply policies in the inbound direction. These basically think of them as request policies, right? And then we can apply policies on the outbound leg of the request processing pipeline, which is sort of response policies, right? And so obviously conversion of payload of response type should happen in the outbound leg of this pipeline, and so we're going to just put it here in the outbound.
So by picking outbound, you're changing the response.
Correct.
Right, got it.
And as you can see, we have here convert XML to JSON. That's exactly what we need, so we're going to drop that in. And it has a few parameters that we can set. And as you can see, it's fairly self-explanatory. Kind of transformation essentially chooses, I mean, it basically, by specifying that attribute, you'll choose the form of the JSON, how this JSON gets, so how XML essentially gets maps to JSON. And for my taste, I like direct better. It sort of generates more concise, easy to read JSON. So when to apply this policy? You can apply it always, but I'm going to say let's apply it only when content type of the response is actually XML.
Oh, that makes sense. You
Right?
don't want to do an XML to JSON conversion if you've got, binary coming back.
Exactly. Moreover, I will say, you know what? We will only apply transformation when actually it's requested by the client. We're not going to return JSON by default, but only when we are asked to return it by, by the caller specifying application JSON in the accept header.
But if I
of the
put
request.
false there, I could force it. I could
Yeah,
ignore what the
then it
client
basically
wishes.
will become default and
Right.
always in the back.
Right, makes sense.
So setting those things, at this point we have the policy set up, so we're going to save it. It propagates to the proxy fairly quickly. And at this point, we can actually go and invoke and see what happens. So let's take a look at back at the Azure API. Open console. By the way, these are actually, I didn't draw your attention to this, but these are pretty cool samples that we generate automatically from the metadata that you can actually copy and paste into your application and run them.
So if I want to know how to call this backend from Ruby, I just click on that Ruby button and I'll see some code that shows me how to call the API from Ruby?
Yes, very true. So these things, and again, these samples are generated automatically, so you don't have to write them by hand. And they are generated on the basis of the metadata that is entered into the system.
Super cool.
So let's go into the console. Let's do 1 and 2. And invoke HTTP GET. And as you can see, we've got 200, and hopefully the answer is 3. And of course, you can see that it comes out as an XML because that's the default type. Mm-hmm. And since I didn't ask for JSON in my request, I didn't get it. So let's add accept header over here and set the value to application JSON. So at this point, all the conditions for the policies are true. Content type returned by the service is XML, and we are asking for JSON through accept header. So at this point, if I actually call it, I should get JSON.
Wow.
Yeah. So nice thing about it is that we now modernize this service, right, without actually touching it. So we have this simple service which takes query parameters, returns XML. Now it actually takes path parameters and returns XML and JSON depending upon what content type you would like. So let's look at something else.
So one thing I'm excited to see is how would you protect that API? So let's imagine we're back in my nightmare scenario sort of 12 years ago, and there's a potential that a partner could bring down my mission critical systems. What could I do to sort of put an end to that?
Very good. Okay. So for that, we have a few other policies, a couple of other policies that you can apply. So those are limit call rate.
Oh, wow.
So this basically arrests spikes. And then we have usage quotas. So those policies actually have to be set up on a product. And I think I actually configured one here yesterday, but I'm going to do it again just to demonstrate you how this thing works. So let's start with limiting call rate.
Right.
So let me just save this, and let's go to the developer portal. Let's just make sure that we can call this service, fairly frequently. So let's open this guy in a new tab so that we don't have to go through this process of clicking on things. So now if I go and do the addition, you can see that I can, call it at will. And at any rate, whatever I can master right now, and every time it's 200, and it works perfectly well. So for this demonstration purposes, let's change that. Let's say that we want to protect this policy. And of course, you want to check for rate limits in the inbound, right? So that makes sense to put it as early in the pipeline as possible. So let's drop limit call rate. And you can see it's a somewhat complicated policy. It is applied to the product, right? Mm-hmm. But you can see that you can specify the limits of calls to the API and even operation level, right, with these kind of things. But we're not going to do this. We're going to just be very simplistic for this demonstration purposes and say, let's limit the call number to one call every 5 seconds, right? And you could have said, 1,000 calls per minute or, 100 calls per second, whatever that number you'd like to have, right, for, whatever your service can bear, you can put it. This will be very good for demonstration purposes because it will be immediately
very aggressive,
easy to see exactly how this works, and then we don't have to wait long for it to start, accepting requests. So let's go. So the policy is applied, so let's go in and make a call. So we're making call number 1, and it's 200. We make call number 2, and we're getting 429, too many requests, and it even tells us how long we have to wait for the for this for this policy for your quota essentially to be renewed, for your call rate quota be renewed. So let's go and demonstrate this again. So you see I'm calling it, and I'm getting 429. And as 5 seconds pass, you get 200, and then, of course, it repeats itself. So this is essentially definitely would have saved your bacon, when you...
Saved me a lot of time.
Exactly. Similarly, you can set, and I'm going to just show you notionally, those policies, all these policies compose pretty well. So you can actually also set usage quota, which really tells you what number of calls and amount of bandwidth you allow your callers to consume over a long period of time. So it can be, I allow you 1,000 calls per week, or 10,000 calls per month, whatever that number might be. It could be even a year, right? And again, you can go down to API and operational level. With your, be very specific. If one of your operations is sort of very sensitive or takes a lot of resources to execute on the back end, you may have actually different rate limit settings or quotas for that operation. And then you can, of course, since you apply this to the product, you can then create products tailored to different customers and give some customers, more capacity versus less capacity. So that's pretty cool capability here. Just to look at other policies here, there's a bunch of policies that we have that actually deal with cross-domain access, right? Which is, in this day and age is very important.
So cross-origin resource sharing.
Exactly,
right?
That's the one. And then JSON-P kind of is a simplified way to handle the same thing. You can find and replace strings in your payloads. You can cache, and which is a great capability. Each instance of the API management service comes with a certain amount of cache, and that cache can be used towards response caching. And essentially what it does two things. First of all, it reduces latency for those cache responses for the callers. Right?
So a call comes in.
Yep.
If the proxy has decided to cache that call, the proxy just sends the response without going to the back end.
Exactly.
Right, got it. That's awesome.
So that's one. And then, of course, also the nice effect of it is that for those calls, we don't actually go to the back end service. And therefore, you can serve more traffic with a certain amount of capacity than you would have been able otherwise. So it's a pretty nice, from the security perspective, we have restrict caller IP so that you can whitelist or blacklist certain IP addresses, etc. You can, rewrite URI, and we are familiar with this guy, right? Because in our Azure API on number add operation, we actually applied that rewrite template, right? We did it in a nice interactive way.
See, so there was a different UI that allowed me to easily create this policy.
Yeah, so we actually created these simplified interactive ways of creating these policies for most commonly used ones.
Very cool.
Such as caching, rewrites, etc. So, but underneath it all sort of works through the policy engine.
Yeah. So you mentioned earlier that you were going to show us the publisher's view of what's happening inside your system.
Sure.
The analytics, right?
Analytics, yeah. So analytics is pretty important. So let's go and check that out. The first view is at a glance view, what we call it a glance view. And here you have presets for time periods that you want to see. You can see today, yesterday, last 7 days, week, up to 90 days. And this graph is actually a composite graph. It shows you a bunch of metrics. Four most interesting ones are calls, response time, bandwidth, and errors. And you can see that everything here looks pretty good.
So
there's
no errors. That's good to know, right?
No errors is nice. Everything pretty much steady as it should be, right? If you have predictable load, obviously if you have spiky load, you want to see a different picture. But essentially, if you know your API and you know the patterns of use, you can quickly sort of with one glance say, okay, it's more or less normal. The other thing we show here is basically the answer to the question: what are your sort of favorite developers, or rather maybe top performing APIs, products, operations, and of course, who are your most active developers? And you can, by default, we sort these entities by successful calls that they've made. But you can also sort it by any other parameter that you want to sort of use, and qualify them for.
So if I want to see which developers are consuming most bandwidth from my service, I can single them out.
Exactly.
Give them a call or something, right?
Exactly. So you can actually sort out, and this is always descending order because we are talking about top, right? So this gives you like top 10, 15, 20, 25 developers or operations or other entities that are performing at peak. So the other tabs are kind of give you a drill down capability. Usage obviously gives you drill down capability into your calls and your bandwidth. And as you can see, here we have presets for dates, but we also can pick an arbitrary time period. We can also filter the information by, look at traffic for specific product. Let's say start a product. No traffic for that one.
Okay.
So the only product that is being actually called through is unlimited. And similar for APIs. Like if you look at Azure API, you can see that we just made a few calls here, right? But the Echo API, is being called consistently throughout a long period of time.
But you created that 10 minutes ago or so?
Which
and
One?
It's already showing the analytics.
Yeah. So it usually about few minutes back, delayed, but you can start seeing, and if you go to today, you may see sort of a little bit more here. So, and of course, you can see also where the traffic coming from, and not surprisingly, actually, it's coming from US, of course, because that's where we are today.
Right. I wasn't lying. Yeah, we are.
So that's another nice thing here is that we're actually showing you where the calls are originating from by using reverse IP lookups. And similarly for bandwidth, right? We're showing it for bandwidth as well. And you can see, our morning exercise with Calc API, we consumed the total of 14.3 kilobytes of data. So that's kind of usage, health. The screen here, the page here, follows the same pattern. There are date presets, custom dates, filters. And then, of course, you can see status codes. And there's a bunch of blocked ones here, right? And blocked ones were generated by us as well. And, we can go actually and see specifically for Azure API, right? And you can see a little bit of blocked calls right there, 11 calls.
Awesome.
That's where we exercise this rate limit call policy, right? Yep. So we show you that we're hard at work protecting your interests, right? Now, we actually blocked 11 calls that should not have been, affecting your service. I didn't configure caching for this one, so you don't see anything. But for the APIs that have caching enabled, specifically for operations, I think maybe this one. You see specifically, right? Get resource, cache. This operation has cache configured on it. You can see that here hits are massively higher than misses, right? So this response is actually cached, and it shows you that mostly responses are actually served from the cache rather than go to the backend service.
That's awesome.
So the backend service pretty much coasting, right? Where we, API management is hard at work here servicing the calls. Similarly, you can look at API response and service response time. API response time is basically the totality of time spent in proxy, round tripping to the backend service, and then, of course, time spent within the backend service. And service response time basically accounts for round tripping and backend service only. And when you line up these graphs like this, you can actually see that the difference between those two is really time spent in proxy, right?
I see. Yeah.
And so you can see here that obviously our service is co-located with API management in Azure, and so it's sub-millisecond response time there.
Wow.
And it's about 2 milliseconds overall, so we are spending about probably around 1 millisecond in the proxy, doing rate limiting, doing conversions, doing tracking, key validation, and all the other things.
Indeed.
Yeah, very high performance.
That's
and you can see that here we have more diverse in terms of where the calls are coming from, right? They're coming from a bunch of places. And lastly, we have this activity tab, which basically shows you, again, same pattern with how you filter data, but here we have essentially all the products, APIs, operations in tabular format with all the associated metrics. So you can actually look at all of this. Now, obviously this is very useful, but what is more useful is the fact that we actually have a management API for API management service, which allows you to actually extract all of this data into a spreadsheet, right, with a very simple sort of
So the analytics data you were showing there, you can pull out of the API for the management API for API management and then play with it.
Precisely.
Super.
All of that data can actually be extracted either in JSON or comma delimited format. Then you can sort of analyze it using other applications such as Excel, do reporting, load it up in Power BI, do whatever you need to do with it.
That's awesome.
Yep.
Awesome. So, great intro to the service. I think thanks, Vlad, for guiding us through that. There's so much more this thing can do, actually. So I want to share some resources with you guys where you can learn more about the capabilities of the service. You'll see our content on azure.microsoft.com/APIM. We have a team Twitter handle as well at Azure API MGMT, short for management. And you can also contact and email the team directly. We love talking to customers and interested parties at APIMGMT@Microsoft.com. So go and learn some more. So we're coming to the end of this module now, but come back. Click on Module 2 because we've got some awesome stuff in store where we'll be joined by Kirill Gavrilyuk, who's the PM lead for mobile services, and we'll start looking at some awesome Azure mobile services capabilities. Thank you.
Thank you.
And clear. Okay, hold on, guys. We're going to do that in one more time. You're looking at the wrong camera.
Oh, sorry.
That's all right. I was trying to wave at you, but I couldn't wave at you. So pick it up right there. Do exactly what you just did, and we'll get the end one more time.
Which from where?
Right after you did the Learn More slide.
Okay.
So I think you said something like, that brings us to the end of this module, and then you did some great stuff after that. So,
Okay. Right. You ready?
Hold on a second. All right, here we are in 3, 2.
And that brings us to the end of this module, but come back. Click on Module 2 because we've got some awesome stuff in store where we'll be joined by Kirill Gavrilyuk, who's the PM lead for mobile services, and we'll be talking about some really awesome Azure mobile services capability. See you soon.
Thank you.